Hello, everyone, and thank you for joining. We are in panel 3, session 1, with the session title being Decarbonization Pathways Using Different Approaches Around the World. I have a few housekeeping items to review, and then we can get started. So thank you to all the sponsors for making this event possible, especially DTE, the host sponsor. Please click on the sponsor link on the left-hand column of your page and visit their sites to learn more about their work. So we have a great lineup of speakers, and after all presentations are given, please join us for the last 15 minutes of the session as the speakers answers a few questions from the chat. And ACEEE will collect any remaining unanswered questions and send them to speakers so they can respond after the conference. So with this in mind, you can see the chat box on the right-hand side of your screen. Please use this box only to ask questions for the speakers and refrain from dialogue between other attendees. If you do want to connect with other attendees, please take advantage of the attendee link. That's also found on the left-hand column of your page. And any attendee who has created a profile can be found there. So in this column, you'll also find attendee resources as well. And these resources contain conference proceedings, attendee list, and an evaluation survey to complete at the end of the conference. Anyone who fills it out and includes their name and testimonial will get a discount to attend the 2023 summer study. So in the program participants link, you'll find information about all of the presenters, including bios and copies of their presentations. Last, please join us at the end of the day for post-panel debriefs to learn about other discussions that you might have missed. Remember, all sessions will be recorded and available on demand after the conference. So now we can get started with our speakers. Our first speaker is Genevieve London. Genevieve is an energy coach at Stillwater Energy, a Portland-based energy efficiency consulting firm. She engages directly with energy managers, both in the industrial and commercial sector, to identify and implement low to no cost energy measures. She specializes in change management and employee engagement in an organization. Genevieve holds an MBA with an emphasis in sustainability and social innovation from Portland State University and a BA in ecology and evolutionary biology from the University of Colorado. And Genevieve, it's all yours.
Great. Here we go. Thank you so much for that introduction, Bertie. It's great to be here with you all virtually. I am looking forward to sharing this presentation with you. It's near and dear to my heart. I grew up in Colorado, so I'm a Colorado native. We'll be talking about reducing Rocky Mountain emissions this afternoon, depending on where you are. And this picture is from the top of Mount Democrat, one of the 58 14ers in Colorado. The presentation this morning will be focused on really understanding how organizations are taking these big, broad goals of emissions reduction and making them actionable. So let's get started with a little bit of history on some core conferences that really drove some of the climate action that we're seeing today. So we're going to take a trip down to Rio in Brazil, and this was back in 1992. There was a conference there called the Earth Summit. This was one of the original Earth Summit conferences. This was where we started to see energy efficiency and greenhouse gas reduction coming into the global stage. So at this conference, the UN framework for conservation and let me get my notes here. Oops. Hang on one second. All right, here we go. The United Nations Framework Convention on Climate Change, or the UNFCCC. A little bit of a hard acronym to remember there. I wanted to make sure I got it right. So that started off in Rio, down in Brazil. And then moving to our next location in Berlin, Germany, was the first conference of the parties, or COP, which in every subsequent year since that initial conference in Berlin was where we have these COP conferences. Moving now to 1997, we're headed over to Japan in Kyoto. This conference led to the development and completion of the Kyoto Protocol. This protocol set binding emission targets for developing nations. Although this protocol had a lot of teeth to it, unfortunately, a lot of the nations that were at this conference decided that this wasn't really for them. There was a lot of economic fear, uncertainty that if we really committed to reducing emissions back in 1997, then it would have some detriment to the economy, especially for the developing nations. So the Kyoto Protocol was not as impactful as it really had intended to be. Our next and final destination on our quick tour here was in 2015. The COP took place in Paris, France. This is where the establishment of the Paris Agreement started. The agreement requires that all countries do their part to slash emissions. And this does not penalize countries for not meeting their emissions targets, but there's hope that in the future, if countries are not able to meet their emissions targets, that there might be some penalties for that. All right, with a little bit of background, we can look forward. So that 2015 was a pretty big year. The Paris Agreement was adopted then. In 2020, this was what we're calling the climate turning point. This is when 196 nations universally adopted the Paris Agreement and committed to limiting temperature rise to 2 degrees Celsius. 10 years from then, in 2030, the attainment of 17 Sustainable Development Goals are supposed to be met. This is important because 13 out of the 17 Sustainable Development Goals are based in climate action. So essentially meeting those goals will ensure that climate action is being made. And then by 2050, world reaches a net zero emissions. So these are big, kind of audacious, broad goals. And often goals like this are a little bit hard to understand from a contextual, organizational level. How do we make these things actionable, understandable, something that we can, really see as moving the needle? Greenhouse gas overview. Anything that needs to be taken seriously needs to be measured and reported. This is something that is pretty complex and complicated, especially when we get into that indirect Scope 3 emissions. There's an international greenhouse gas accounting standard and framework that helps entities report and manage greenhouse gases. For the context of today and for this presentation, we'll be mostly focused on Scope 1 and Scope 2. All right, so Colorado Energy Office, with a bunch of other entities, put together the Colorado Greenhouse Gas Pollution Reduction Roadmap. This roadmap was finalized earlier this year from a variety of stakeholders, and these stakeholders were able to analyze different scenarios, different target goals, depending on how much reduction we were looking for. So out of this report, there are really 4 focus areas that we're focused on: clean electricity, transportation electrification, energy efficiency, and oil and gas measures. To be a little bit more concrete with these 4 focus areas, we've got a couple other examples of what these measures look like. Continue a swift transition away from coal to renewable electricity, make deep reduction to methane pollution from oil and gas development, accelerate this transition to electric vehicles, and electrify buildings and promote building efficiency. So we're taking all those big, broad goals from the UN SDGs and then from the Paris Agreement and making them understandable, actionable, meaningful. So we're getting down to the details here. For the work that I do, I see a lot of greenhouse gas emissions incorporated into SEM, Strategic Energy Management. There are many core tenets of SEM, and some of those are up on the screen here. We've got executive engagement. For greenhouse gas reduction emissions to be a part of this, we're looking for executives to incorporate GHG financials into their analysis, thinking about the payback and life cycle analysis costs when they're approving projects, approving more low carbon or decarbonized projects that come across their desks. We want to promote the use of greenhouse gas related metrics, so making sure folks on the floor are able to understand what they're kind of tracking towards, what the goals are, how to make sure they're on track for those. And then employee engagement is going to be really important here, especially as we think about change management. Engaging employees in greenhouse gas language, education, and awareness is going to really go a long way. It's kind of an ambiguous topic and hard to really wrap your arms around, so driving that education is going to make a big difference. And this links especially close to culture change and behavior change. Driving that desire is going to be part of a persistent change in a facility's culture. And then lastly, we've got champions and teams are really responsible for leading this change and being in charge of greenhouse gas monitoring, emissions reduction on site. Of course, it's not just the team or the champion's job to make sure that's happening, but keeping someone or a group of people on track and tracking on this is going to move the needle. Colorado Energy Office is in their pilot program of the Industrial Strategic Energy Management Program, or ISEM for short. It's a year-long SEM program, and it's built to deploy SEM principles. Unlike traditional resource acquisition SEM programs, there are no mandatory energy savings requirements for the program, meaning there's no need for a kilowatt hour or therm goal. There are also no measurement or verification expectations. Typically, this is something we see in lots of different demand-side management programs. For the Colorado Energy Office, this has been a pro because they're able to be a little bit more flexible with the delivery of the program. We're able to really focus on SEM topics, and there's a little bit more customization and right sizing for greenhouse gas integration. In this current cohort, there are several organizations that subscribe to the UN Sustainable Development Goals and the Paris Agreement. This is really important. They're at an organizational site. They're really pushing the envelope for what coaches need to bring to the table, and then also the Colorado Energy Office. So there's a little bit of a different push and pull from participants in this example. Greenhouse, so for this program in particular, we don't have M&V models, but we do provide them energy models, and those can incorporate greenhouse gas tracking and metrics incorporated into those models. So we're using emissions and generation resource integrated database, eGrid, to serve as an entry point for greenhouse gas tracking for these participants. As opposed to the Colorado Energy Office ISEM program, we've got some results from other administrators from across the nation. This is survey results from the North American SEM Collaborative. We're looking at really areas of SEM programs that are lacking or needing a little bit more work as it's related to greenhouse gas emissions tracking, all that good stuff. So we're seeing that there's not a lot of tracking going on site or off site related to greenhouse gases. There's some identification of greenhouse gas opportunities, but there could be a little bit more. Program administrators are supportive of carbon accounting, greenhouse gas accounting, but oftentimes they're not able to really make a lot of movement on that because of their focus on energy efficiency mandates. So we've got a few current challenges that have been a reflection of those activities. So we've got, as I mentioned before, program administrators are really focused on that energy efficiency mandate, making sure that they're hitting those targets, and that's closely related to the cost effectiveness thresholds. We're also noticing that there's a lack of experience with greenhouse gas reporting or really understanding how to incorporate it into the SEM curriculum or SEM programs. That's not to say that there can't be experience that's gained, it's just hasn't been a part of the skill set at this point. All right, so some of our core findings and challenges so far from a programmatic perspective, with a summary of those analysis, is there's a lot of support for greenhouse gas and sustainability reporting, yet program administrators don't have the ability to put it into action. Organizations solely focus on energy efficiency as opposed to this incorporation of energy efficiency goals into the larger greenhouse gas reduction goals. So if we're able to kind of wrap those up into broader goals, that would be really helpful. And then there's a lack of alignment at a customer, organizational, local, and state government level. We're not finding this in Colorado in this example. There's really great lockstep between organizations, the state, and then the headquarters of an organization to really make movement on greenhouse gas reporting and reduction. But typically we do find there's some in alignment between all three of those different groups. And then there's an opportunity to track on-site generation, identify electrification opportunities, and conduct informational greenhouse gas and renewable workshops. So really driving that education and awareness is a great place to start. From a participant perspective, we've got international organizations are much more likely to focus on greenhouse gas reporting and emissions reduction. Several of the organizations we work with have headquarters that are in Germany or other parts of the world, and this is something that's really important to them, and it's trickling down from the corner office. Alignment to broader, more global goals drives climate action. So, we're used to this in an energy efficiency landscape. Linking them to sustainability is going to be really important. Linking GHG goals to sustainable development goals is a great way to make this more impactful and seem like you're doing something that serves this greater good. Participant utility state alignment propels action. Making sure that there's that lockstep between each level is going to really create a supportive environment for making positive steps in this direction instead of creating barriers along the way. And then we're also seeing that greenhouse gas reduction is a competitive advantage right now. If you're able to do your process in a low carbon way, this is going to keep you competitive and viable into the future. So this is definitely something that's positive from a business perspective. All right, this is my final slide, just showing, really what the landscape is looking like from even from this last year, from the U.S. re-signing the Paris Agreement back in January. We've seen a really strong push to get climate action plans released, and Colorado's in the middle there, but we're seeing a lot of other states doing a lot of work as well. I think one of my main points of this conversation today is to drive that these massive goals can translate to everyday actions that we can all do. And sometimes these things that feel really, really big, if you break it down to small enough pieces, it's something that you can do every day. And that's what we're seeing from the Industrial Strategic Energy Management Program. All right, that is all I had for y'all. Thank you so much.
Great. Thank you, Genevieve. That was excellent. So we're going to transition right into the next speaker. And that is Michael Dean. Michael has nearly 10 years of experience in energy efficiency and sustainability, successfully providing services to more than 450 industrial, commercial, institutional, municipal, nonprofit, and large final emitter sites. Michael developed a passion for energy efficiency and sustainability from an early age and graduated with a degree in sustainable energy engineering from Cork Institute of Technology in Ireland. And Michael has lived in Canada for 5 years, working for the Clear Result as a senior strategic energy management program manager. He leads the Canadian SEM and Energy Managers Support Services program team, who deliver programs that help participants drive behavioral, operational, and capital replacement changes through a holistic approach to achieve energy and carbon emission savings and non-energy benefits. And Michael, the floor is yours.
Much for the introduction, and hello everyone. Thank you for joining me today. I'm excited to present out on my white paper, which was on decarbonizing industry through the adoption of strategic energy management. So my name is Michael Dean. I work for Clear Result. Clear Result is North America's largest energy consultancy company, which includes SEM programming as well as the provision of on-site energy manager services. The focus of today will be strategic energy management, and I'm excited to go through that today with you. I'm a senior program manager looking after strategic energy management and energy manager support services programs right across Canada. Looking forward to talking about a few of the programs that I deal with in Canada, and also other programs, SEM programs that Clear Results deals with in the US and across Canada also. I want to give a special shout out to Sam Day, pictured here. Sam is our senior technical manager. He's responsible and manages the energy modeling team within Clear Result. So that team is responsible for creating energy models for all of our SEM programs. Those energy models track the performance of our participants as they move through the SEM programs, and those energy models are used by our clients to pay out incentives to the participant at the end of each program. Sam was instrumental in helping me doing some of the statistical analysis when we were comparing different data sets. So thanks again, Sam. So the agenda, just want to talk through what we'll be looking at today. Introduction and acknowledgements we've already done. Want to start with a problem statement and why should we care. Then want to move to the abstract overview. So when the abstract got submitted initially, we wanted to answer 4 questions. So throughout this presentation, we'll be looking at those 4 questions. We'll also have a brief outline of the methodology, and we want to look at the results and considerations that came out of that analysis. Before we go right into the meat of the results and considerations, want to make sure that everyone has a common understanding of how strategic energy management works. So we'll spend a slide or 2 on that. Then we want to look at a GHG focused base case at a glance. So typically our SEM programs have an energy focus. So typically our clients are either gas utilities or electric utilities. But in the case of Alberta up in Canada, our client was Energy Efficiency Alberta, and now Government of Alberta, where the sole focus was actually GHG. And up there, we delivered a capital program and an SEM program solely based on GHG. So they're going to be the base case that we compare all other non-GHG focused SEM programs to. Then we'll look at results and considerations coming out of the 4 questions that we asked through the white paper. Then we'll wrap it up by tying it all together and questions and answers. So why should we care? So the image here shows the global greenhouse gas emissions by sector. In 2016, global GHG emissions were around 50 billion tons of CO2, and that has increased. So energy, including electricity, heat, and transport, is the largest slice of that pie, and it makes up in around 3/4 of the world's emissions. To achieve decarbonisation, we require expertise across many sectors. There's no one-hit wonder, no single action or solution that can help us reaching net zero, but a continuous improvement system like strategic energy management can certainly create a strong platform with its principles being applicable to most or all sectors that we can see in this illustration here. SEM is currently being applied to commercial, institutional, industrial, multifamily sectors at the moment, but there's also ClearResult are also looking at some pilots to look at fleet electrification in more recent times. So it really shows that those principles can be applied to quite a lot of sectors and industries. For the purpose of this event and the white paper and this presentation today, we'll focus specifically on industry, which makes up around 1/4 of the world's emissions. So abstract overview. So I mentioned the 4 questions that we wanted to kind of look at throughout the white paper. The first one was, how do GHG focused programs compare to GHG focused capital programs? So SEM versus capital, essentially. We're going to look at the cost efficiency there as well as other key metrics. Are GHG focused programs more successful in decarbonising industry than energy focused programs? So typically 95% of all of the programs that have been delivered for SEM across North America are focused on a particular fuel, be it electricity or natural gas. But we want to see if an initial focus on GHG is actually more successful in decarbonising industry. And then thirdly, we want to look at what aspects of an SEM program need to be adjusted when shifting to GHG focused program, and what are the associated benefits. And we'll look at a few major elements there that need to be considered to make sure that that is successful. And lastly, what considerations need to be made when allocating funds to energy efficiency programs, and in general when considering decarbonisation. So we're going to look at energy management, capital programs, and renewables also. So to start off, to make sure that everyone has a common understanding of what strategic energy management is and gets the most out of this presentation, we want to look at what is SEM and how does it work. So the goal of SEM, strategic energy management, is to achieve energy savings through low cost, no cost efficiency improvements, usually through operational and maintenance or behavioral changes. But we do identify potential capital incentive projects as well that are passed over to capital programs. So it's kind of a one-hit wonder that catches all potential projects on the site. The snail diagram that we can see here shows that SEM is a continuous cycle whereby we take a holistic approach to energy management. So just to look at the snail diagram here, I just want to point out a few elements. So from the offset, we would work with a client and we would recruit a cohort of facilities or participants. Typically, a cohort can range between 8 and 12 participants, and they're usually located, geographically located around a central point in around 2 or 3 hours from a central point. And the reason for that is when we're doing group workshops, we want to make sure that those participants can get to the group workshops and they're not traveling too much. Obviously, that was pre-COVID, where in the last year and a half, we have been delivering SEM successfully, completely virtually. But hopefully, as COVID restrictions lessen, we'll be able to get back to that more in-person kind of setting, because it certainly helps with a lot of peer-to-peer learning and build relationships and trust within the community of the cohort. So when we're trying to recruit participants into the cohort, we try and identify 2 key folks right from the very offset. Those folks are the executive sponsor and the energy champion. The executive sponsor is someone in upper management who has the ability to allocate funds and resources to make sure that SEM is successful on site. So basically, they're the person that when an email comes from them, everyone knows that it's serious. So we need that person to make sure that SEM is taken seriously and people don't see SEM as a flavor of the week within the organization. We also have an energy champion. So the energy champion is the main point of contact that the SEM team will have on site. So they're the person that makes sure that what we're recommending to implement, the energy model that we are tracking the program with, is keeping up to date and that we're being successful on site. So they're a very important role. So typically an executive sponsor may spend 20 to 30 hours dealing with SEM type measures on site, and an energy champion would probably spend around 4 to 10% of their time on SEM. That range is there because depending on the organization, they may have some really good initiatives and structures internally already that we can piggyback on. SEM is trying to piggyback on what's existing and complement and inform the participant. We're not trying to create a whole bunch of extra work, but all of the energy team members, be it an executive sponsor and energy champion, are existing employees of the organization. So we want to be very mindful and jealous of their time and make sure that they're getting the maximum benefit as soon as possible from the program. So initially we bring engineers on site and we identify measures on site. So it's either low cost, no cost measures or capital measures. So from that energy scan, we would typically identify 40 to 60 measures, which would be given to them on an opportunity register. I would call it more of a menu than a list. By no means we ask our participants to implement everything. So what we do is we prioritize that list based on level of effort and level of savings and what the participant is comfortable with. So that measure list of 60 opportunities will be put down to a one-year plan, let's say, of 15 or 20 measures that they're comfortable with, they've committed to, and they know that they will get good benefit from. In parallel to all of that, then, we are measuring the site's energy performance. So we create whole site energy models to track their performance, and those energy models are used at the end of the program to pay out that participant incentives. From an organizational point of view, then, we also do an energy management assessment. So that energy management assessment assesses the participant from an organizational point of view to see how they're getting on in terms of structures, policies. We mark them on where they are. They tell us where they'd like to be. So we create a specific goal to them, a 1 or 2 year goal, and then we create an action plan to make sure that they get to their goal, and we're supporting them throughout that. So it's within the first 6 to 8 months, the participant has an awful lot of the tools that they need to be successful. And really with the low cost, no cost measures, we're trying to get our quick wins. The energy model acts as a pat on the back and a confirmation that what they're doing is creating impact. And we're really trying to accumulate momentum on site right from the very offset. So the majority of Clear Results SEM programs recruit a cohort of participants, as I mentioned, and include collaborative group workshops where all the participants are together in a room. Obviously pre-COVID, now that it is virtual, we have virtual settings, but the idea of that is to get organizations to share ideas and kind of share their stories, share their success, their barriers, and kind of create that peer-to-peer learning in that community within the cohort. We have one-on-one coaching and support and continuous technical and energy modeling and engineering support throughout. So whatever they need, we're there to help them be successful. So the three mediums, I guess, of cohort delivery are those three mediums that I mentioned: the collaborative group workshop, one-on-one coaching, and technical support. Make sure that they're successful and encourages organizational commitment, identification, prioritization, and implementation of energy measures, and then the energy modeling and reporting as well helps them be successful and measure success on site. So want to talk about the Alberta program. So in Alberta, Clear Result was successful in winning work for Energy Efficiency Alberta. Energy Efficiency Alberta was very different to our typical programs where we're looking at units of energy. With Energy Efficiency Alberta, we were looking at GHG, so tons of CO2 was the focus from the very offset. So back in 2018, we began and ran their capital program as well as their strategic energy management program. So on the SEM side, participants were able to partake in that program who were 5,000 to 100,000 tons of CO2 consumption annually. So then by the numbers, On the capital side, in the capital program, there was 69 capital projects completed and implemented through that program. On the SEM side, then we had 60 participants across 250 SEM facilities, and you can see there that we had a really good representation from industrial, commercial, institutional, and municipal type facilities. So these numbers make up the large data set that enabled us to create some really good conclusions from this white paper. So the first question: how does GHG-focused SEM compare to GHG-focused capital replacement programs across key metrics? So what we found was in Alberta, where we did that comparison because we ran both programs, that a 2-year SEM engagement was over 3 times more cost effective in comparison to the capital program. And it's worth mentioning that a lot of the capital projects that took place in Alberta were oil and gas focused, which would have a really good dollar in versus ton out. For the rest of an industrial sector outside of oil and gas, we would expect the cost efficiency to be much greater. So it is at least 3 times more cost effective, is what I would say there. The SEM program also had a higher realization rate of claim savings, and that is due to our continuous energy modeling and working with the participant to do that energy modeling. So the summary of, I guess, what we found in Alberta, and has been reported and studies have been done on this before, but SEM in parallel with a capital program is the most effective way to run a program. And from that, we see that we get an increased likelihood of newly installed equipment being operated efficiently because of the good practices from SEM. It also assists with realization rates and the sustainment of savings, and increases the savings performance of an installed project. And just to add on to that, in 2015, Energy Trust of Oregon conducted a study that revealed that facilities that participated in an SEM program completed 50% more incentivized capital projects than non-SEM participants. And the reason for that is they have an increased awareness of the best projects on site. And because we're training them on how to sell projects internally, they're also more successful in getting throughput. So capital project studies weren't just dying at a study, they were actually going from study right through to project implementation, which is of course very favorable if you're running a program. So secondly, are GHG focused programs more successful in decarbonizing industry than energy focused programs? So obviously the majority of the programs SEM programs run in North America right now are energy focused and not GHG focused. So what we did find, GHG focused programs were more effective in decarbonizing industry. So this is where Sam Day came in. He did some statistical analysis of our data sets. We used Alberta as the base case with the GHG focus, and then all other energy programs where we have dual fuel, we compared them to Alberta. So what we were able to summarize was that GHG focused SEM participants saved on average 3.8% compared to 2.82% for non-GHG focused programs respectively, meaning that GHG focused programs saved just under 36% more savings than non-GHG focused programs. So what aspects of an SEM program need to be adjusted when shifting focus to GHG, and what are the associated benefits? So there were many elements that needed to be adjusted and considered to make sure that the program was successful, but these 5 here on the slide are certainly probably the most important. So first off here, we have energy modeling development. So for all of our other programs, we created gigajoule or term models for natural gas and kilowatt hour models for electricity. In Alberta, where there was a GHG focus, all of our models reported out tons of CO2. So what we had to do there was take the fuel and multiply it by the emission factor for that year or whatever it may be. So we needed to be cognizant of that. Then those emissions tracked the performance, and incentives were then paid out based on those tons of CO2 savings. So for a lot of the programs that we deal with, fuel switching is either off the table, difficult to do, or not incentivized. So in Alberta, where there was a GHG focus, allowing for less carbon intense fuels was always considered and on the table and incentivized. What we did find, though, that out of the 200 SEM participants that we had in our portfolio, that only one facility implemented a fuel switching project, and maybe that highlights the difficulty of switching fuels from one type to another. So just wanted to mention that. And that was a CHB project for a commercial building. So measurement, identification, and planning. So typically, if we're running a program for a utility, let's say, we will focus on that utility. So it may be electricity. So what's in scope is electricity, pretty much everything outside of electricity, outside of scope. The good thing with a GHG focus program is that everything is in scope. So we are able to identify the best opportunities for the participant that would get them the most emission savings. So we would be looking at natural gas, electricity, biomass, diesel, propane, everything was in scope. So we had a much better and a much stronger list for the participants to prioritize. And because of that, we were able to get some really good savings and results. Also, the incentives were different. So typically when we're running an energy program, we're doing unit of energy. Every unit of energy gets a certain dollar out. For the GHG focus program, we gave $1 per ton of CO2. So in Alberta, it was $40 per ton of CO2 saved. Emissions factors, then we needed to update emissions factors as fuel intensity changed. For the most part, we saw the most change with electricity. Natural gas more or less stayed the same between the different program years. But as the electricity grid became cleaner, we had to make sure that those emission factors were updated when we were tracking the performance in the models and reporting out the savings at the end of each year. So finally, last question here, what considerations need to be made when allocating funds to energy efficiency programs and in general when considering decarbonization? So want to start off with the energy efficiency pyramid here. So we can see 3 tiers: Tier 1, energy management; Tier 2, capital replacement; and Tier 3, renewables. And what we can clearly see as you move up through the different tiers towards the top of the pyramid, the cost and oftentimes the complexity of implementing a measure increases. So as we mentioned, energy management is over 3 times more cost effective than capital replacement. So that kind of puts it into perspective, kind of where we are with the cost increase. I think Tier 1 energy management is very well placed at the bottom of that pyramid, because we have found that energy management activities really do set a foundation for organizations to have a higher impact as they move through the different tiers of energy efficiency. So we want to make sure that an organization isn't just putting a brand new piece of equipment and, for example, putting in a brand new air compressor, but they have loads of leaks on site, or putting in a new lighting system, but they've lights on all the time. So we want to make sure that we're being cognizant of that. So SEM participants also complete 50% more incentivized projects. So that also shows that the more time an organization spends in Tier 1 and gets the maximum potential and builds that foundation, they will get more as they move up through the different tiers of energy efficiency. Program sponsors and regulators should allocate energy efficiency funds with the value of each tier in mind. So it needs to be considered that when money goes into energy management, that it is also going to help out the future of capital replacement and renewables. So those considerations need to be made. For decarbonization to be effective, there needs to be a synergy between the different tiers. As I mentioned before, an organization should not get a brand new piece of equipment if they have bad practices or bad PM structures on site. Going back to compressed air, we want to make sure that we're not giving a new site a brand new compressor if they have a whole bunch of leaks on site and there's malpractices of compressed air. Similarly with renewables, we want to avoid and do not want to give a site incentives for putting in a brand new solar system if they're using lights all the time when they don't need to. So making sure that we're being cognizant of that and managing the energy and optimizing what we have from the outset makes sure that the different tiers are more impactful as we move up through the pyramid. Then the conclusion, SEM programs are over 3 times more cost effective than capital programs. GHG focused programs prove to be 35.6% more effective in decarbonizing industry than non-GHG focused programs. The GHG program informed us that some key SEM program deliverable components need to be considered and adapted to deliver a successful GHG SEM program. So that was the energy modeling development, the fuel switching, the measure identification, and emission factors and incentives that we talked about a little bit ago. And using an energy management type program as a base will optimize the performance of capital and renewable technology based programs. So that's that tiered approach that we looked at. And lastly, then program sponsors should ensure that energy efficiency programs are in synergy to gain maximum benefit from all programs. And that is me. Thank you very much for listening, and I'm looking forward to any questions that you have at the end of the presentations today.
Great, thank you, Michael. Excellent presentation. And our last speaker today is Luan Nguyen, and Luan is a PhD candidate in energy economics at Griffith University. He has more than 9 years of experience in various positions in oil and gas industry, such as manager, researcher, data analyst. And in addition, he possesses an MBA in economics and a BE degree in industrial economics. And today he's going to be talking to us about industrial energy efficiency and determinants, a stochastic frontier analysis with firm level data. Luan, the floor is yours.
Thank you, Amata, for a nice introduction. Good morning from Gold Coast, Australia, ladies and gentlemen. Thank you for having me here today. My name is Leon. I'm a PhD candidate at Griffith University and Gold Coast. Today, I'd like to introduce you our paper with the title as shown on the screen. And this paper we have just complete with, I just have complete with my supervisor, Dr. Sama Ratnasiri at Griffith University, and Dr. Liam Wagner at the University of Adelaide. Let's start with just history. Like a study of Zhang done in 2011 conclude that the most investigated developing country have only marginal change or a steady decline in energy efficiencies. That is in the paper in the Energy Policy Journal. And the main reason here is that most of developing countries were trying to promote their economic growth by increasing scale. The energy efficiency is kind of overlooked when the technical level is still limited. However, Vietnam is one of very few developing countries interested in and having many policy to promote energy efficiency very early on in early 2000. However, the results are not really commensurate with the effort of the government. As you can see in the first figure on the left here, the required energy to produce the same amount of GDP or normally called energy intensity in Vietnam is one of the highest all over the world. And you can see that the red bar is indicate for Vietnam is much higher than the purple bar, which is Chinese energy intensity, and it's also much higher than the rest of the world. And more severely, in the second figure on the right, you can see the trend of energy intensity in industrial sector over time. While the trend over the world is declining, the trend in Vietnam is, which is expressed in the red bar, is keep increasing alarmingly. So that situation leads to a question that what are the most influence factors to energy inefficiency in Vietnam industrial sector? And in literature, actually, the extent study have tried to address this question. However, the answers are incomplete. They are either mostly focused on developed country industry or using aggregate data in case of developing country, which cannot reflect well the impact factors. So in our study, we want to have a more in-depth view with micro or firm level data, and we are going to examine the impact of 3 broad aspects. First is the government intervention through the regulation. The second is the firm managerial behavior, and the third is technology adoptions. And in each group aspect, there are sub-factors as shown on the screen here. To discuss about the technical energy inefficient, let's briefly explain by this figure in theory. There are three firms A, C1, C2 here all need energy and other input to produce the same amount and output. And in neoclassical economic, we can easily define the production function to explain the relationship between all inputs and output. And that production function can be shown graphically at an isoquant curve, as you can see on the screen. From the viewpoint of production efficiency, it is accepted that the firm may consume more than the necessary level of input to produce a given level of output. The firm C1 and C2 here lie on the isoquant curve of production function are considered as energy efficient. Meanwhile, the firm A which need more energy than firm C1 and need more energy and as well as other inputs than firm C2 is considered as energy inefficient. In one study of Dr. Gilboy in 2008, he proposed the separate energy input distance function to measure the energy inefficiency for the firm level data. In that proposal, there is one way to measure energy inefficiency by the biggest proportion that the firm can reduce all input equitably while keeping the output unchanged. So this method then have been applied in many other studies, include study for the micro data or aggregate data too. And in this paper, we set up the model that follows the separate energy distance function to evaluate the energy inefficiency in firms, which show in the first step here, that is mathematical model. And because we want to evaluate the impact of exogenous factor on energy inefficiency, so we also need to set up the second step following the first step, as you can see on the screen. And the method we apply here to estimate is the stochastic frontier analysis that proposed by Dr. Baptiste and Dr. Coeli. So based on that method, we can estimate the first step and second step simultaneously. And finally, we can calculate the energy inefficiency index to measure like the efficiency level of each firm as well as the efficiency level of each industry and sector. About the data, so in this study, as mentioned before, we will use the firm level panel data over the period 2011 to 2015 of 8 major industry in Vietnam. That include chemical, cement, tire, steel, paper, textile, garment, and electronic industry. So there are around 14,000 observations, and it account for approximately 77% of all total industrial energy use. And here is a descriptive statistic of the data set. I will move on a bit quick on this slide. So due to the limitations, limit size of presentation screen, so then we just show here the second part of estimation that estimates the impact of all exogenous factor on energy inefficiency of each industry. The factors are categorized into three groups in the rows. And we also have 8 different estimations for 8 industries that show in 8 different columns here. Because of the technology, the output and the input of each industry are different. So the way we estimate it, the model separately have to avoid the heterogeneity issue. And in addition, to avoid the heterogeneity problem, we consider the production process only. And for the firm produce multi-products, we only consider the main productions. The results here are all in all sectors are highly significant that we can use to explain our result. However, we want to use more illustrated explanation. So we will calculate the energy efficiency index to show the finding as in the following slide. This is the first finding. So in terms of energy efficiency performance, we can confirm that Vietnamese industrial sector are heavily energy inefficient based on this estimation. Here we graph the box plot of all energy in an efficiency index of all 8 sectors over the period 2011-2015 together. But please be note that we do not compare across the sectors. We just compare within the sector because of the heterogeneity issue. As you know that the upper border of box plot indicates the 75 percentile point. And from this figure, we can see that the border of most industry are lower than the energy efficiency index level of 0.6. And if energy efficiency index equal to 1, it means that that is an efficient level. So from this figure, it means that more than 75% of firms in most sector can theoretically reduce energy consumptions by more than 40% to be efficient. That is that happened in most of industry in Vietnam. So that is a massive amount. And as you can see, the trend of box plots in each industry over time here, the energy efficiency, you can see that it's rarely improved in most industry, while there are clear declining trend in some industry, like the textile or paper industry in the fifth and the sixth column. Now we will have a close look at impact factor analysis. And for regulatory impact factor, we'd like to show here our investigation on government interventions. It is very common in Vietnam and in many developing countries that government can involve deeply into business, that to make some state companies. So based on that, the firms can be categorized into 3 different groups. The first kind of firm are the sole government firms, which have more than 50% capital share from the government. This kind of firm get a strong support in terms of financial and regulation, but any decision that made by the firm is also regulated by the state. The second kind of firm is a share capital ownership firm, where capital share is from the state is less than 50%. They got less financial and regulation support than the first group. But in exchange, they have their own management board for decision making. And the rest can be classified into the sole private, which is not linked to government at all. And in the literature, all studies suggest that the government-related firms are always less efficient than the sole private firm. But here in this study, we found the interesting finding that the firms that have share capital ownership actually outperformed other two types in terms of energy efficiency. Of course, that the sole government firm is the worst one in terms of energy efficiency, but the share capital ownership is the best one. In terms of managerial factors, here we want to emphasize 2 findings related to the impact of firm size and import activity. There is one widely accepted idea regarding to the firm size is the bigger firm, the more efficient. That's because of economies of scale. And I believe that all of us already know about that and agree with that. We also expect to have the similar implication in our study. However, the results here are so totally opposite. As you can see on the first figure on the left here, here we have the box plot for the small firm, medium firm, and large firm. And the small size firm are most energy efficient in case of Vietnam, while the large firm are the most energy inefficient. It surprised us at the beginning, but actually it's explainable. So as you know from the first finding, there are like most of the firms in Vietnam are energy inefficient. And among inefficient firms in all industry, smaller size mean that they are more flexible and to adjust and to restructure than the bigger size. So over time, they can improve their energy in efficiency situations. And the figure on the right hand, we examine the impact of the import activity on energy inefficiency. So we initially expect that the firms that need to import material and energy, which is more expensive than the domestic products, would have a better management skill to have a higher efficient level. However, the results show clearly that the firms that have no import activity perform better than the ones that have import activities. The underlying reason here include the limited import infrastructure and complicated legal procedure. That firm want to import the product have to go through many red tape procedure. But those ones are from the government side. Besides that, this result also imply that the firm's planning process are not really proactive in terms of handling delays in importing material and energies. So that is from the firm side. Regarding the technological factors, we investigate 3 variables. The first one is the fuel that we found production that using coals are more energy inefficient than the one that using other energy types. The result of the first variable is not showing here. We want to emphasize 2 other variables. The figure on the left, we want to show the impact of the founded time where we find that the firm established after 2008 is more efficient than other firms that established before 2008. There are 2 reasons here. As you may know that in 2007, Vietnam joined WTO, World Trade Organization. And from that point, this country received a huge investment from abroad into industrial sectors. So then from that point, industrial sector received more funding, and then they have a better technology, have more advanced technologies. So then they can improve the situation of energy efficiency. And another point that we want to emphasize here is that there is an energy crisis in 2000s. So let's recall the energy crisis in 1970s. That energy crisis is like a wake-up call for the developed country to focus on energy efficiencies. So we believe that the energy crisis in 2000, on the other hand, will be the wake-up call for the developing country like Vietnam. And the result here imply that after the energy crisis in 2000, somehow the new established firms have more awareness about energy efficiency. So then the new established firm have a bit better result in terms of energy efficiencies. So we try to investigate the data, and so this figure on the right shows the impact of annual investment on energy efficiency. So here we expect that the firm that have annual investment should have better energy efficiency index. The reason we expect just because if we have more investment, they can improve the situation. However, as you can see on the screen here, the firm that have annual investment have a lower energy efficiency index. That's also a surprise result. We try to investigate the data, and then we found that actually the annual investment in this period are mostly expansion investment. And as you can see from the first finding, because most of the firm are energy inefficient. And when they are highly energy inefficient, more expansion without technological improvement lead to more severely inefficient. To summarize, so in this paper, we have tried to find the clue of what impact on energy inefficiency in Vietnam industry, and why these countries start their campaigns to improve the circumstance quite early, but it seemed not really successful. And we found out that all 3 broad aspects, which are regulatory, managerial, and technological factors, all have strong influence on energy inefficiencies. And interestingly, those effects that we found here are mostly contradictory to the finding in more developed countries. That so then we hope that our finding here could show some insightful lesson for other developing countries that are leaning towards energy efficiency. And that's all for my presentation today. Thank you very much.
Excellent. Thank you, Luan, for that presentation. And I think we're transitioning now to our question and answer portion of this session. So lots of questions in the chat, and so I'll just run through a few and see how many we can get through. So Genevieve, we'll start with you. We had a few questions. One to start, does Colorado have a recommended carbon price? And maybe that's kind of a starting point for maybe all the states.
Sure. Yeah, the Colorado legislature is using $46 per ton as the social cost of carbon for energy planning by the Colorado PUC.
Excellent. And so how detailed does the GHG accounting have to be per site? And do different sites have their own factors due to PPAs or on-site generation or third-party suppliers?
Sure. That's a great question. For the purposes of this program, we didn't get into all the details of carbon or GHG accounting, but for each site, you would need to get into that detail to understand what they're contributing from a carbon standpoint. But we didn't get into that.
Excellent. All right, we'll shift to you, Michael. We had a number of questions. Maybe just to start, there was a question about why EE Alberta decided to go with the GHG emissions instead of a kilowatt-hour reduction for their programs.
Yeah, so Energy Efficiency Alberta was a government agency. So the governmental party at the time assigned them to run GHG because as part of that party's initiatives or plans or action plans, they wanted to reduce GHG emissions in Alberta. So that was the focus, and Alberta also has a carbon tax of $30 a ton, so that's the reason.
Excellent. And so I think you had a slide comparing GHG to non-GHG savings with percent savings. And so is that percent like percent of cost or percent of GHGs or energy? Can you expand on that?
Yeah, that's a percent of GHG savings. And I guess in a way it's also percent of energy savings. And the reason I say that is because we applied the same emissions factor to the GHG focus programs, to the non-GHG focus programs, to make sure that we are being fair in comparing the two. So what we also did is we weighted and normalized based on NAICS code or sector type. We also normalized based on the size of the participants, because some of the participants up in Alberta were extremely large because of the oil and gas focus and the huge industrial sites up there. So we normalized for all of that and weighted that accordingly.
Excellent. And I guess maybe one more question for you, Michael, before I shift to Lon. How were GHG reductions and savings calculated? Was this a modeled number, or were they based on measured and actual reductions?
So kind of a modeled actual in a way. So what we did was for all of our participants, whether it's GHG focus or energy focus, we take a 2-year baseline. So we get all of their energy usage, and we look at their energy usage. We also get data from the site, energy driver data. So energy driver data may be the weather, it may be production, it may be downtime, and we see how those correlate. For the 2-year baseline, then we create a model of actual versus what the model is predicting based on the drivers within the site. Then when the program starts, as those two lines separate from each other, the modeled and the actual, that's our energy savings. Then basically what we're saying is, because this participant is in the SEM program, they're having this much of a delta between pre being in an SEM program versus after being in an SEM program. So an organization could actually increase their energy usage, but also have energy savings because they become more efficient. So if your production goes up with your energy usage, but you're doing it more efficiently, you'll actually get energy savings.
Makes sense. All right, we'll keep moving around the room, so to speak. Juan, do you have a sense for your study, the fuel mix for the different industries that you were evaluating? And do you know if that fuel mix is changing over time for Vietnam?
Yes, thank you for this question. Yes, actually in this study, we also consider about the energy mix, and we have a couple of variables to address that. For example, we have the energy cost, we have the energy mix, and we have a type of fuel. So then we have that information, and the fuel mix not really move over time because like it's been like based on like cost benefit analysis, and many productions team prefer to use the cheapest one, for example coal, even they know that that one is not really efficient, and also that is not environmental friendly. However, because of like the cost benefit, so they still feel that that is one is cheaper one, and they still feel that that's why the energy mix not really improving over time. But the thing is that like as we mentioned, as I mentioned here, and then there are some variables that I do not include in this presentation. There's a kind of fewer. So we found that the kind of production that use more advanced technology and like more eco-friendly energy like natural gas or electricity actually have to improve the energy efficiency index.
Excellent. And I guess so. Luan, your presentation was kind of struck a note, I think, where there is maybe a lot more attention that needs to be going to countries that don't necessarily have all the same resources as Europe or the US. And I'm wondering whether there's any takeaways from the analysis that you did, where are there actions that companies or government can take to help improve the energy efficiency, for those industries? Was there any like key factors? I mean, there was a lot of, counterintuitive results, it seems, but how do we take that information now and act on it?
Yes, thank you for that question. Actually, that's what we are thinking on the second paper, because in this first paper we want, as you know, that not many paper or many study focus on developing country. One thing is because of data. I think that is the main problem. Luckily, we have a data from Vietnam because they have many campaigns from the very early on. So we try to identify, like, because here we still look on three very broad aspects, and then we try to identify which is the most important. Then we try to go deeper to see, like, for example, in regulatory factors, there are some like incentive program from government that to promote. But that one we already consider, but we found that that is not really effective in this study. So we didn't go deeper, but we intend to go deeper in the second paper. Yes. Yeah, and actually we consider like some incentive program, like whether they have like program for the industrial zone, or some kind of like the central province. They have a more focused program to promote the energy efficiency there, but it's not really make difference at the moment.
And I guess one last question for you, Luan. You made the point about the data availability, and I'm wondering whether how translatable is this kind of analysis, or even your results, to other developing countries, and maybe what kind of data do they need to have to be able to do this kind of detailed analysis?
Yeah, so that is interesting question, because even like for Vietnam, we want to go deeper, like focus more on specific industry, so we can have a more like much better implication. For example, we focus just only sector like cement, but we don't have much detailed data to do that. So to answer that question, I think that it's not easy. Like it depends on what kind of level you want to analyze. Even for developed country, yeah, data available everywhere, not like many published data. But if you want to go really deep into some specific industry, it still not have enough data to make an analysis. So for developing country, I suggest at least you have like some countries should have like the economic surveys and industry and improvement, some program they apply, and at least like here we just have data for 5 years. At the moment you can have more, but we just got 5 years. But at least like even for enough data, it should have a good a good panel data for at least 3 or 4 years.
Excellent.
So it's still challenging for developing country, I believe.
Oh, I believe it.
Yeah.
And I think Genevieve, we'll finish on with you. For the work that you did, you were focusing on scope 1 and scope 2, but I'm wondering about scope 3. I mean, that can be pretty big, pretty significant. And do you have thoughts, or have you done any work to think about how to engage stakeholders to tackle these scope 3 emissions?
Yeah, scope 3 is big, and it's pretty complex. But I think, you know, for now at this point, doing a lot around driving awareness and engagement at an organizational level is going to kind of start the conversation, and then really this is for us focused on kind of the cultural change component. But I think there's a lot for all of us to learn from a scope 3 perspective.
Awesome. And I realize my timing is completely off, and actually we still have tons of time for questions, so excellent. Let me just keep pressing. Another question for you, Genevieve. How important is it for companies with PPAs to track carbon intensity of energy use?
I think, yeah, I don't have a great answer to that one. This feels big, and I think there's a lot to think about in terms of carbon intensity. We've seen in Colorado at least a lot of energy is from tri-state generation, so there's a factor that's been applied to their carbon intensity that's applied into their energy metrics there. But I think it's the more we can account for any of these nuances, the better, to get a clear picture of kind of where we're headed and how to make important impact.
Excellent. Michael, let's kind of shift back to you. There's a question: how did you recruit to obtain SCM GHG participants, and were there certain drivers to that participation?
Yes. I guess initially with a little bit of difficulty, to be honest, because typically with the SCM energy focused programs that we're running, we can utilize the relationships that utility clients would already have with participants. So whether it's gas or electricity, they would have some key account manager or some list that we can go through and reach out to people to see if they're on the program or want to be part of the program. So we had an outreach team, and we created target lists, and we had to do that all ourselves. The utilities themselves were actually not involved in the Alberta program. It was solely run and funded by Energy Efficiency Alberta at the time. So initially it was with a bit of difficulty, but once we kind of got into rhythm and worked with the client and kind of got a good business case up, we kind of got up and running, and we worked with different chambers of commerce, different associations, and utilized as much as we could to kind of create those connections. But in terms of the business case and selling it, initially when we're talking to the likes of executive sponsors, I think that incentive is quite beneficial in getting organizations to take the jump. Because, yeah, in Alberta, we basically offered $40 a ton up to a cap of $50,000. So it was a lot easier for them to make that decision to jump into the program. Then once we got into the program, their focus or their attention really dropped off the incentives, and they started seeing the benefits of the program in every other way. So whether it's benefits of energy bill savings, upskilling staff, continuous improvement, employee engagement within the organization. They just saw so many other benefits aside from the incentive, but the incentive was certainly good to kind of catch them initially to get them into the program. So I guess that was the focus. And because there was a carbon tax as well in Alberta, it certainly helped them to avoid that taxation as well. So yeah, I guess they were the main elements there.
Excellent. And I guess another question, so if the program covered non-utility fuels, how were the incentives funded? And were the utility program funds allocated to GHG reduction in non-utility fuels like diesel?
Yeah, so the utilities themselves were not part of the program or funding the program. Of course, the utilities would have given all the participants their utility information when we were creating energy models and throughout the program and stuff like that, but they were not involved in it. So yeah, I guess, what was the second part of that question? Sorry, Marty.
Were utility program funds allocated to GHG reductions in non-utility fuels?
So they were not, and yeah, it was solely focused on GHG. So if we had diesel or whatever on site or propane on site, as long as it saved emissions, you were getting that $40 a ton. But by and large, the largest emitters on the site were natural gas and electricity. The likes of diesel, propane would have been part of some of the participants, but by and large they made up a very minute amount. So the majority of the focus was on natural gas and electricity. But if it saved emissions, you got incentives.
Excellent. Luan, I'm kind of curious because, you know, we heard the presentations from Michael and Genevieve on these different programs, you know, SEM, that they're able to engage with companies and employees and other stakeholders, and the same with Genevieve. How, if any of that has happened in Vietnam, and was that any of that part of your study? And maybe we'll kind of do a little round the room here just to kind of gain your perspective first, Luan, from what you were seeing from the data you saw and what kinds of activities were happening. And then maybe Genevieve and Michael, you can also kind of comment on where programs like what you're working on right now could help move the needle for Vietnam and other developing countries.
Yes, that's a very interesting question. And when I listen to the presentation from Genevieve and Michael, I also thinking about that issue, that idea as well. Yeah, it's hard for me to answer it clearly because it's, you know, that it's also depend on like the how I can say, like the orientation of the government as well. But in my point of view, I think SEM should be like maybe it's suitable for us at the moment, maybe. Yeah, but actually we I know that in Vietnam they also consider some like team or some program to promote energy efficiency in industrial sector, but not clearly that, because at the moment I think that even for our country when they try to have some promoted program like this, but it's still in macro level. It's not really focused on industry, or maybe I haven't had like enough in-depth view. But in my point of view, I still feel that like the government have not yet have a very in-depth solution to promote that. So most of the program at the moment is quite in macro level, and then that make the effective is not really strong at the moment. Yeah, but yeah. So if you ask about which program that I prefer, I think that's SEM, maybe the program that I'm look I have more, how I can say, it's a bit lean more to work about that. But to make a clear statement that I think that is should have a better view than me. Yeah.
Excellent. And maybe Genevieve, if you might have some thoughts on this as well.
Sure. I'm actually going to point to Michael's presentation. One of the graphics that really stuck with me was the baseline energy management of your pyramid, that tier 1. I think that's such an important kind of framework to keep in mind as we kind of bring in more and more nuance to energy management when we're thinking about carbon and other greenhouse gases, kind of adding to that level of, you know, continuous improvement, making sure the right people are involved, you're getting buy-in from executives, and other key stakeholders. So I think, starting there and building that as a place for your program to start is going to be a really great place to start. And I think, there's a lot of, at least from what we've seen, this tie into the UN Sustainable Development Goals has been such a neat way for folks to feel like they're adding from a very personal level to these broader goals, and they're very tangible, understandable, and you can relate to them pretty quickly. So I think that's a really nice way to engage employees and help them be part of the solution.
Excellent. And Michael?
Yeah, I certainly agree. I think starting off, especially in countries or industries or provinces or states or whatever it may be, where energy efficiency is at its infancy, I would certainly suggest that energy management program is certainly a good place to start, just to kind of assess where the market is, assess where organizations are. We touched obviously on the cost efficiency being better with energy management, but what we see with capital programs, they obviously are fantastic. But if you put in a capital replacement program or a renewable program right into a place that is in its infancy with energy efficiency, then you may not get the impact that you would like. So you should always optimize what you have first before you start moving up to the different tiers. I guess that would kind of be my thoughts on it.
I'm wondering what you think, because when you describe the SEM program, you're saying, okay, well, we're looking to identify these low and no cost strategies to improve our energy efficiency. But as Luan had noted, where sometimes the really impactful fuels are still super cheap, more cheap than other alternatives. And so what are your thoughts about how to address that particular type of challenge?
Like with Alberta, focus on the largest emitters. Like if we're talking about emissions, the fuel with the largest emissions should be focused on first. So if your electricity is being generated solely by hydro, maybe that's not a good place to be focusing on. If you want to improve climate change or reduce emissions, maybe you should be looking at your diesel, propane, and natural gas on the site.
Good point. Good points. Let's see, maybe, Luan, I was wondering, for the analysis that you did, is this able to account for really transformational types of technologies being brought into the economy, where the factors are really very different and maybe not well represented? How would that kind of make, how could that be accounted for as in the analysis that you did?
Yeah, so thank you for the question. Actually, I just have one extra information to following Michael's previous answer. Actually, I'm thinking about, like, for example, in case of our countries, not only like I believe that like the manager of the company know that like the more eco-friendly energy are more efficient than the old one like coal or electricity. But actually, it's also depend on like how to not only the change, because you know that changing from this type of energy to another energy not easy like that. They have to change the production line, their own technology, and somehow it's not really available option at the moment for many countries like us. For your question, so then actually for this kind of study, as I mentioned, like we still have a really broad view. So then for the other developing country, I believe that this one is not too hard to get the same kind of analysis, because this data is kind of like very general data for input and output of any firm that they should have, like any statistical agent should have it. for deeper view, I believe that we, even for Vietnam, we still have challenging to get that data. For example, if we want to focus on one industry to see if what we can change to make it that become like viable, or even like we know that, for example, for fuel, as you mentioned in this previous question, for many industry, we know that for that kind of energy is totally inefficient. So, and it's also pollute a lot of emissions. But that is like, if we propose to change it in short term, it's impossible. Yeah, so then it depends on many other factors. But to transport for the other developing country, I believe that to have, firstly, let's take a look on like have the same look like what we have it here. Like if the government focus on, like if the government have some intervention in firm, whether it's good or not, where government should do it. And for the firm that, for example, there is one thing that we find here is the firm size, for example, whether we should just increase the size in the developing country or not. Or just consider like just a medium size or smaller size, maybe become more effective. Or if you need to import, whether you should consider about improve your management skill, because when you import and you have a very not good infrastructure, you need to go through many red tape procedure. So you have to have a really good planning skill to make sure that you can reduce weight and reduce the time as well.
Excellent. Thanks, Juan. And actually that wraps up our session. We are at time. Many thanks to our excellent speakers for sharing their presentations today, and to the audience for coming with your questions as well. And we'll have those questions available after the session, and we'll make sure everybody gets their questions answered. So thank you, and have a great rest of the conference.
Thank you very much.
Thanks so much, everyone.
Bye.